Hello, my name is Subhan Khan, and the title of my project is Simulator for Testing and Validation of Control Laws on a Quadrotor Helicopter. Testing and validation on a plant is required when a novel control algorithm is developed. That plant can be linear or non-linear, that depends on the plant. The major problem in conventional unmanned aerial vehicle is the stability and trajectory control. So quadrotors are more stable than the other conventional UAVs and preferred in a control community for testing and validation of control laws in a real-time environment. So there it is, how a quadrotor that it looks. So it has 4 propels, as we have seen in the figure. Anyhow, quadrotors, also known as multicopters, and gain popularity because of the trajectory control and higher stabilities. Their major advantages is simple mechanics and reduced gyroscopic effects, and power drain due to 4 rotors, motors in control is one of the drawback for this. Anyhow, this project is divided into 3 categories. The first is simulation, the second is animation, and third is GUI. I will show you later. And this project is the first ever implementation on a quadrotor helicopter as a teaching assisting tool to make students understand the fundamentals of control system engineering. And this project is also a platform to compare PID controllers, proportional integral derivative, and linear quadratic regulator LQR control techniques. And tools are the MATLAB and the RAM Builder. Anyhow, now I would like to show you the first part of the project. That is the GUI part. Here it is the operations that can be used for this project, and this is the guidance or the input, you can say, which is provided in the form of manual form, ramp, step or sign. It's the ramp response or step response, which you've seen in the undergrad students that use, and they got confused most of the time. Anyhow, these are the control options, the control techniques, that is PID control or LQR control techniques can be used. Kalman filters, LQR gains and PID gains can also be set from this project. And the major thing is the transient responses. It is better to teach students what are the transient response when a system works. Poles and zeros, they can also be seen from it. And disturbance in the form of air can also be provided here, which is controlled by this Kalman filter. Now, first I would initialize the parameters. There it is, the parameters are initialized, and let's say I'm going to use ramp input, and a PID controller is going to control this ramp input. So what the students are going to see, first they will see the animations in the VRAM Builder. There it is. So you can observe it from here that the quadrotor helicopter is going in a ramp input. There is passing with the time, as I've shown, and students can observe it from different mods, that how virtually the aerial vehicles worked and how actual at the end they show the behavior. As I said, that we have provided the ramp response, so the system is working in a ramp response and PID controller is controlling it. Assuming that it is stopped at this point, let's suppose, then what the students can see, they can see the what are the positions which they provided and what they obtained. These are the actual and these are the desired. They're desired and actual positions on the X, Y, Z. They can see from here. And also they can see the angles which are produced, roll pitch yaw, the attitude angles. There it is. Then the velocity, that's what the velocity actually produced by the system. At 15 times we have seen it. And then they can compare with the error position plots. There it is. This is a proper teaching tool. Then for the PID control, they can see the overshoots produced by this PID controller, the peak time, the rise time. These are all transient responses. Assuming that we stopped it here for the overshoot, let's suppose. And then I chose LQR control, that how they're going to compare these 2 control techniques. And assuming ramp input is still selected, there it is. We're going to start the animations again. Now again you have observed that the system is started and it is controlled by this time LQR, and it is going in a ramp form. So the students will observe the difference of 2 control techniques used here. This is the airport mode, and I'm going to stop it here on 14 seconds as I stopped for the PID controller. On the other hand, I will also show you the interface of the simulating model and the GUI model. Let's suppose it is stopped here. So how they're gonna compare, there is overshoots. If you select it here, for the LQR comes here. So meaning by this, they can easily detect that, all right, these are the difference between these two control laws when we are using a ramp input. And again, what they can see the position plots by using the other control technique. They can see the attitude plots, and also they can see the error or the growth plots. Even start, stop, and pause, they can also be provided from the graphical user interface. So pause and zeros, they can also be provided. It will load and it will be uploaded again. Anyhow, there it is. The another module for our project is basically a simulating model. This simulating model is interfaced with the graphical user interface, and these are the VR sync for use for the animations. This is the LQR control technique, and this is the PID control technique used for the system. And this project, as I said before, it's a great platform for students to understand the concepts of control engineering, and this is the first ever implementation of a Quadrotor as a teaching assistant tool. Poles and zeros, they can also be observed from for any student if they're getting confused. What are the poles of the system? There is a continuous pole, as you can see, of the system, and if they are interested to see the discrete poles, they can also see the discrete system poles. So I'm Subhan Khan, and this is my project. Thank you so much.